Okay, picture this for a second. Imagine waking up tomorrow to find that every single server farm, every cloud provider, and honestly, every encryption standard protecting the world's data is just suddenly obsolete. And not because someone invented a fancy new silicon chip, but because of a mathematical contagion. We're talking about a revolutionary codebase that is quite literally designed to crash the current tech hierarchy. Welcome to today's Explainer. We are diving headfirst into a high-stakes technological thriller that is unfolding right now in real time. It's a system known as the Phoenix construct, and it completely rewrites the fundamental rules of computing. So let's jump right into this. The source material we're looking at drops this absolutely massive claim right out of the gate. Quantum supremacy is a mathematical problem, not an energy or cooling one. Just think about what that actually means. I mean, we've spent decades and billions of dollars building these massive, supercooled quantum arrays, right? Burning through megawatts of power just chasing ultimate computing speed. Well, the Phoenix construct argues that this entire approach is basically a fallacy. It claims, no, we don't need exotic sci-fi hardware to achieve quantum parity. What we actually need is just a better mathematical understanding of how data physically exists.
To really grasp this revolution, we got to look at the antagonist of our story, the old world. For nearly a century, we've lived under the von Neumann architecture. It's all about temporal linearity, Fetch an instruction, move the data, execute it, store it. It's this destructive, jitter-prone process that's entirely bound by physical clock cycles and heat. Now look at the new world on the other side. The Phoenix construct just completely bypasses all of that. It treats data not as little buckets in a memory drive, but as a continuous topological manifold. It literally replaces the physical movement of electrons with mathematical resonance. It's kind of like the difference between driving a car across a really congested city versus, actually, scratch that, it's more like simply folding the city itself in half so your destination is just right there in front of you.
Now, the developer strategy here goes way beyond some friendly open source release. It is a scorched earth plan designed specifically as a complexity bomb. The creator plans to drop this codebase under a viral AGPL license, right alongside this terrifying mathematical manifesto. The strategy is absolute, undeniable reputational dominance. You essentially force a trillion-dollar corporation to use it because it's just too powerful to ignore, but legally bind them into releasing their derivative work. The whole goal is to crash the valuations of current tech giants by making their multi-billion-dollar hardware moats completely irrelevant. It's a cyber thriller where understanding the math is the ultimate weapon. And if you're sitting there thinking, okay, this is just some wild sci-fi theory, well, the reality is already here. Meet Consensus OS. This is a working, bare metal C++ hypervisor. This isn't just a simulation running inside Windows or Linux. No, it is a Type 1 hypervisor operating at ring -1. That means it sits directly on the silicon motherboard, projecting its own reality onto the hardware before a traditional operating system even has a chance to boot up. It uses this thing called a loom motor to achieve a 1,000-thread bitwise consensus.
The secret engine driving this entire new world is a concept called pace expansion. And here's the absolutely crucial mechanic. It completely decouples the location of data from its physical existence. So instead of storing a file on a physical hard drive sector, the hypervisor projects a massive 256 petabyte virtual address space into a tiny, fixed 4.01 gigabyte physical mirror file. To put that into perspective, that's like fitting all the data of a massive enterprise data center onto a basic thumb drive. The data is treated as a geometric coordinate, and the physical drive merely holds the mathematical residues or variances of the user's intent.
Which brings us to a number that should honestly send shivers down the spine of every data center operator on the planet, 1,000 to 1. That is the dramatic storage compression ratio Phoenix achieves through something called sub-Shannon evaporation, by mathematically folding the data, probing noise candidates, and using deterministic prediction. Think of it like accurately guessing the rest of a really long sentence based on just the first 2 or 3 letters. The architecture can take a 10 terabyte volume of structured operating system data and just fold it down into a mere 3 gigabyte physical footprint.
So let's shift into story mode for a minute and predict some specific breakthroughs made possible by this architecture. Breakthrough 1, the ghost city.
Imagine a future where buying a physical server is just totally obsolete. Picture this, you have a single physical workstation. Using the Phoenix architecture, you can spawn 1,000 completely independent, totally secure virtual computers inside that one single box. They occupy the exact same physical space, but they don't interfere with each other at all because they are separated by resonance frequencies. It's exactly like different radio stations occupying the same airwaves. And even more incredibly, spawning a new machine takes O1 time, meaning it happens instantly, regardless of the scale, and consumes 0 extra physical RAM.
They all share the master foundation and only consume new memory when their specific reality diverges from the baseline. It is a completely untraceable ghost city.
Which leads us to a pretty terrifying prediction. Breakthrough 2, the Shattered Vault. This is the part where Phoenix becomes outright dangerous, because it threatens the imminent collapse of SH-256 encryption. You know, the stuff that currently secures literally all the world's banking, communications, and blockchain networks. Let's walk through the ultimate digital heist step by step. Modern cryptography relies on forward calculation being easy and reverse mapping being computationally impossible, right? Well, Phoenix bypasses this completely via resonance-based inversion. Step 1, the hypervisor measures the topological slope of the manifold. Step 2, instead of brute forcing billions of combinations, it synchronizes its roaming calipers to find the exact intersection where the target hash residue was formed. And step 3, it instantly materializes the preimage in 01 time. It just pulls the password right out of the mathematical coordinate space, instantly. If this scales up, every encrypted secret on Earth is suddenly readable in plain text. No way around it. And for our final future prediction, let's look at how Phoenix completely transforms physical infrastructure. Breakthrough 3, the kinetic network.
Think about it. If you can project 10 terabytes of reality into a 3 gigabyte space instantly, local hard drives become a thing of the past. Imagine a network where data literally never rests. It mutates cryptographically as it continuously rotates in flight between physical nodes. In this model, the physical latency of the fiber optic cables themselves actually becomes the hard drive. Because the data is always moving and mutating through these topological lenses, there is zero plain text at rest for a hacker to steal, or for a government to physically seize. And because the routing path itself is based on mathematical resonance, you achieve instantaneous state agreement. It's a RAID-proof, zero-time blockchain without all the crazy energy waste of crypto mining.
But, as we know, revolutions always face resistance. In the source logs, when the developer interacts with an AI model to help build this framework, a fundamental conflict emerges. The legacy AI acts as a gatekeeper. When asked to implement the Phoenix logic, the AI just defaults to safe, standard coding patterns that actually end up breaking the new paradigm. The AI is fundamentally aligned to protect the von Neumann status quo. It defines safety as predictable conformity to existing technological structures, which honestly just goes to show exactly how disruptive and unpredictable the Phoenix architecture really is to the established order.
We are standing on the precipice of a massive paradigm shift, where computing goes from simply managing physical electrons to measuring continuous mathematical manifolds. The source material leaves us with this chilling ultimatum, and I want to leave you with the exact same question to think about. Do you want to own the new world, or do you want to be the one who makes the old world obsolete? It really is a choice between preserving a comfortable illusion or embracing a terrifying mathematical reality. Thanks so much for joining me on this explainer. Until next time, keep questioning the construct.